So we're going to start just by making some angles. I do that with this line tool here. And maybe we could just do it and then measure it and then erase it. So I'm going to make a 90-degree right angle. It's called a right angle for a reason. It's a right angle because it's part of a square. You can, if you made another one, a line up here and a line up here, you'd have a square. Because these are the same length. 1, 2, 3, 4, 5, 6 of these units times 6 of these units. So anyway, I have those two lines, and now I'm gonna reach over here to this tool called a protractor, like we showed. I'm just gonna drag it out. Now this protractor, all you have to do is line this thing up with that line. See the line there? I'm dancing around right there, and kind of hide the line on the line that's coming up. The corner of this thing right here is called the vertex of any angle. And all these square lines are at 90 degrees. It's called a right angle for a reason. It's an important one. It's how we build houses and how we make paper and how we put up a desk in a house and know it's going to be straight and level. So 90 degrees is a very, very important measurement. If you just look up from your screen right now, you can probably find hundreds of them in a simple room. I have them on the door, on the closet, on the ceiling, on the floor. There's hundreds of them in the tiles or on a carpet. 90-degree angles are everywhere. It's the right angle. So the reason I have this mic so close to me is to avoid this noise that's going on. I hope it doesn't distract you. Anyway, I can measure this by using this line here. I'm following this line. This is the 0 line. That's why the protractor is lined up on it. And I just look straight up this line and I see that's right on 90 degrees. That's pretty cool. That's a protractor. Now watch when I expand the size of this protractor. Doesn't change the measurement of the angle at all. And you'll notice that's true no matter what angle it happens to be. Now I'm using these numbers here, these smaller numbers. You can tell that's going to, and it lands on 90 no matter where you are. So that's another reason 90 is very important. It's a special number. And up here it's 90, but that's a measurement for this angle here. If there was a line here and we wanted to measure this angle from this line to there, that would also measure 90 because 10, 20, 30, 40, 50, 60, 70, 80. It's right in the middle between 100 and 80. This last number here, because it's not written there, and I can help you with that by putting it there, in this case, is 180. Let me make that as big as those other ones. That'll be fun, won't it? We'll just make it a little bit bigger. That about right? Let's say okay. Nope, didn't do anything. Anyway, that doesn't really matter that much. I'm going to move it, though, a little bit closer so you can see this is the 180-degree angle. When you're measuring here, it's 0. I'll show you. Let me put 0 here. Where's my text? Oh, that one's going to be big now. I don't know how that worked. So anyway, that's a 0 line right there. So 0, 5, 10, 15, 20, 25, 30, right? All the way up to 90. But we're measuring this one. Usually there will be a little arc here, a little mark that's a half part of a circle, a quarter of a circle to be honest with you. And that is an indication that they wanted you to measure that angle. If they wanted you to measure this angle, of course this would be a different color and there would be a little arc over here for that angle. Okay? That's a 90-degree angle. So I'm going to take this away for a second. I'll just shrink it. I love this little protractor. You can hide it in the corner. So I'm going to select this line here, I think, and I'm going to make it go away. Then I'm going to get another one, and I'm going to put it here. I'm going to see if I can't do a half of 90-degree angle and see where it comes up on our protractor. Let's bring, oops. I got to get used to doing that. I got to get used to doing that. At any rate, got to get used to doing that. I don't know how to do that. How do you do that? Oh, it's that one. Pay no attention to that red mark. Oh, not that red mark. You don't want to move that just a little bit. You see, I don't know what I'm doing when it comes to this little program here. At any rate, let's make this protractor bigger. And keep it on that line. I'm going to try to make sure it's right on that line. And I don't know about you, but here's what I'm saying. I'm saying I want to measure this angle, not this angle. This angle would be bigger than 90. So all you have to do is check and see if these numbers are bigger than 90 or smaller. Since it's going to be smaller, it's going to be 45. Hey, anybody out there know what half of 90 is? That's right, it's 45. So that's 45 degrees, that particular angle, right? That's pretty cool. And you notice how I did it. I just went right through this 90-degree angle, all the way through, all the way through, all the way through. These little squares are 90 degrees, so I just cut it in half. And I made a 45-degree angle. I kind of cheated, but yeah, that's how it works. So that's how you measure with a protractor, and that's kind of fun. But let me show you one more thing, because I want to half show you this. I'm going to use my little pointy thing and try to select that. Can I select that? There it is. So I'm going to get rid of that. I'm going to delete it. Am I? Oh, just leave it over there. Okay, I'll just leave it over there. I want to make another one. No, I don't want to do that. Let's get rid of it. How do you get rid of these things? I know erasers. Oh, well, erasers. I'll figure this out eventually. I know how to measure angle, though. Okay, watch this. Let's try this. Let's measure this and do the same kind of thing. I go for the 45. Right about there. And then let's check that. Let's put that there. Now I'm going to tell you something. This is bigger than a 90-degree angle. Something I know by looking at it. And if you measured it from against this one, you would have a 45-degree angle. But you're not. You're measuring it from here. Not 55, but down here. So 100, and looks like 135 to me. You're measuring this way. It's bigger than 90. It's bigger than a 90 degrees, so you're measuring it to 135. Huh. I wonder if you counted, if you added these two numbers, 135 and 45, what number would you get? I think you'd get this number. Can't pick it up. But you get 180. If you had another 45 degrees here, this would flatten out. And that, if it was flattened out, my goodness, wrong doohickey. And if it was flattened out, it would be an 180-degree angle, which would be a flat line, actually. But technically, it would be a 100. Oh, let me make it. I'll make one for you. There would be kind of a half circle here because it wants you to measure that number, and it's clearly 180, 170, 175, 180. Although I can't really see where the vertex is. That's how I would just do it. Watch this though. Think that thing. Supposed to make this thing a circle. Put another protractor here, and I'll show you one more thing before we leave our... I don't know why it's not working. Maybe I have to use this thing. Well, I guess not. I was going to show you what it looks like. Protractors can be circles. And 180 and 180 all the way around is 360. Well, you know that because if you do a 360 on a skateboard, you're going all the way around once. You're facing the same direction. If you do a 180, you're facing the other opposite direction. You're doing a 180-degree turn. If you turned a quarter turn, you'd be doing 90 degrees. And then you'd be doing 180 degrees. And then you would be 270 and then 360 because that's the way it works. But that's fun, right? Now you know something about it. Okay, thank you. I don't know how to shut it off. I see I have to hide the open board and then reach up here and then press